Hi friends, do you want to know what is local variable inference feature in Java and how to use them? Then this video is for you. Let us quickly look into agenda. Right? We will see what is local variable inference feature. Inference feature in Java is not new. So we will briefly see the history of this inference feature in Java, followed by valid use cases where you can use it, and then the error cases where we cannot use this feature. Finally, we will see the couple of cases where it is very useful to use this feature. Right? So without taking much time, let's get into the topic. Local variable type inference feature is used to declare, or it can be used only for the local variable. So while you are declaring the local variable, you have to declare with var reserve type name. Yes, we usually declare the variable type name, say with the type of object is going to hold, right? Like say if the variable is going to hold the string object, so we are going to declare that with the string type, or with our custom classes like employee, person, because if it is going to hold with, if it is going to hold that employee object or person object, right? But here you are going to declare that with var reserve type name, right? So what will happen? So compiler is going to infer the target type. Okay, so it infers the target type by the code, and then it replaces that var with the target type, and then it is going to write the byte code. Yeah. So because of this, there is not going to be a runtime, any runtime overhead when you are using this feature, because the compiler takes care of that, right? Writing the target type. So when JRE runs it, so it knows what is the target type. Yeah. So var is not a keyword exactly. So I have mentioned it as saying reserve type name. Okay, why it is? So because of this, your already existing code, if you have used any method name, variable name, or package name with the var as the name of the package or variable name, it is not going to affect anything because of this new feature in Java 10. Your code is going to be backward compatible, right? So it is not going to impact. You don't need to change those names, right? Because it's just a reserve type name, it's not a keyword. You can go ahead and use this feature. Now we have seen what is the local variable type inference, the basics of it. Now let us go into the next topic, brief history of inference feature, right? In Java 5, generic feature is introduced. So as shown in the yellow box, while creating an empty list collection, you need to mention, okay, so what type that empty list will contain, right? So you no need to mention that. Yeah, so the compiler can infer that based on the left hand side of the initialization statement when you are declaring the variable string list, right? It is going to hold the string object in the list, so compiler can infer from this left hand side of the initialization statement, so you can skip it. So this is what introduced in Java 5. In Java 7, when you are creating a collection and when you are writing that initialization statement, in both the left hand side and while creating the object in the right hand side, you need to mention what are the object it is going to hold. Like here the key is a string and the value is a list of string, right? So it is redundant, right? So it's the same thing you are mentioning in both the sides. So you can omit while creating the object. Okay, so using the new keyword. So that is where this diamond operator came into picture, right? So the compiler can infer from the left hand side of the initialization statement, right? So then in Java 8, the lambda has been introduced. Okay. So again here, when you are writing the lambda, so when you are taking any input method parameter, so you have to declare the method parameter name, but it is again redundant, right? So based on the interface and whatever is given in the left hand side of the initialization statement, compiler can find what is going to be your input parameter name, right? So based on these value, you don't need to provide the data type of n. Okay, so the input parameter, the compiler can infer it, right? So now in Java 10, so they have extended this feature for initializing the local variables also, right? So right now inside the main method, the x is an local variable. Okay, so you are going to put var type. So the compiler during the compile time, it can infer based on the value in the right hand side. Okay, it's going to be a string, right? So that's how the compiler will infer the target type. Okay, now we will go into the next topic, okay, where we will see the valid use cases where we can use, right? So it can be used in static initialization block. Okay, so as shown in this sample snippet, okay, so this is a static initialization block. So inside that, any variable, okay, when you are initializing it, you can initialize or declare it as var type. Okay, the compiler will infer the target data type. Okay, so in this case it will infer as a string, because in the right hand side you are giving a string. So in static initialization block, when you are declaring a variable, you can use this inference feature. Okay, and the second type is as a local variable. We have already seen this, right? In a couple of slides back we have seen this, so I'm not going to go much deeper into this. Now let us go to the next use case. So we can also use this to declare an iteration variable, right? So here in this snippet you can see in the line number 6, an int array is declared. Okay, when you are using an enhanced for loop, so you have to declare a variable to hold the value of each item in the array, right? So there you can use, instead of a original data type, you can use var, and compiler will take care of inferring it, because it knows what is the array's data type, right? It can infer and it can substitute it here. Okay, so now let's look into the next use case. You can use it in the looping index also, like say in the line number 7. So the looping index variable x, you no need to declare it as an int. Okay, you can mention it as an var. So based on the value in the right hand side, the compiler will appropriately put a data type. Okay, so the next use case, you can use it as a return value from another method. Okay, yes, it's a little bit different from the previous use cases. See here in the line number 10, the local variable is an x, so it is again a local variable because it is inside a method, main method. So you could ask, this case we have seen already, but we have seen it by initializing an value here like a hello world, right? So instead of that, you can also call another method. Okay, so though even we call another method, you no need to declare the data type as a string. You can mention it as an var. Still you can consider, still it is a local variable, so you can mention it as an var, and compiler will know what is the return type of get value, which is a string, and then it will be able to infer the data type of x, right? So that is what the mild difference, where you can also use it where you are getting that value from another method. Okay, and the next use case is you can use it as a return value. Yeah, so in the line number 5, you are declaring a get value method and the return type is string. So inside that method you can declare the result with the type var. So this is also a valid use case. Okay, we have done with all the valid use cases. Now it's time to see where and all we cannot use. Okay, so we cannot use this local type inference feature, local variable type inference feature for the class members. Okay, it's only for the local variable. So if you are trying to declare a class member name with var, then definitely compiler will show error. Okay, and the next error case is we cannot use it in uninitialized local variable. Okay, so like in the snippet line number 7, here the var we are declaring the variable x, but we are not initializing it, right? So if you are not initializing it, think like how it will be, compiler will be able to know, because this feature is going to happen at the compile time, right, not at the runtime. So if you are not initializing that variable, then definitely compiler will not know, without the value it will not know what type it has to replace it, right, or what type it has to infer it. So definitely if you want to use this feature, you need to initialize the local variable. Okay, this is very important point. Okay, now we will see the next error case. You cannot use it to declare the parameter name. Okay, so inside a method. Okay, so compiler will definitely throw error. So again, it's an extension of what reason we have seen in the last slide. So compiler will not be able to know, right, like what data type it has to infer, because there is no value for x, and definitely it cannot be used as method return type. Okay, so within a method you can declare an local variable x with var and you can return that, but you cannot, in the signature you cannot mention var. Okay, so in the method signature, you cannot put the return type as var. Okay, so we can generalize like it. Like in the method signature, you cannot use var. Either it can be return type or it can be even a parameter type. Okay, which we have seen in the last slide. Okay, the next scenario is we cannot use for the variable initialized with a null value. Okay, so this is a kind of a variant which you have seen in the couple of slides back. Okay, so where we declare var x, that's it, we don't initialize it. So here you're initializing it but with the null value, right? So null is really a value where you can declare or initialize for any variable type, right? It can be a string, it can be an employee, it can be a person, so it doesn't matter. You can declare all those variables with a null value, right? So there is no means for compiler to know what is a target type, right? So this is one more scenario where we cannot use or declare the local variable with var. Okay, we are in the last section of the video. So here we will see a couple of scenario where I felt we will reap the benefit by using this local variable type inference feature. The first one being, while you are declaring a local variable of type which is having a long class name, right? So you can just mention that in the right hand side of the initialization statement, so that in the left hand side you can use var and then compiler will infer it. Okay? This will reduce, or even the size of the line also will be reduced, right? But the second one is a very important one. Okay, so we can use to access a non-denotable types. Okay, what is non-denotable types? Okay? So when you are creating an anonymous class object, like in the line number 13, we are creating an anonymous class object, okay, with the class member variable like count and then the method get count, but still you have to use the variable type as object because it's an anonymous class, right? So here we are declaring the variable o. So in the line number 19, you definitely will not be able to access count or even get count method. You cannot call because the type is object, and then it doesn't know any method or variable apart from what is declared in the object, right? So definitely you cannot call. So this is where this local variable type inference feature is very helpful. Like in the line number 20, the same thing what you have seen from line number 13 to 17, but here you are declaring the temp with the reserved type name var, right? So if you do this, so in the line number 26, you can access the count or get count method on temp object, right? On the temp variable basically, right? So this is where it is very helpful to access the non-denotable types. That's all for this video. I hope you liked this video. If you really like the content, please like the video, share it with your friends and subscribe my channel. Thanks a lot and see you soon in another video.